Hello people, this is another section 4.5 video. I wanted to give you a real world example. This time it's about free fall, which is when you've dropped something and it's falling and it's just getting faster and faster and faster until it hits the ground and dies. And through this problem, I also wanted to give you some tips on how to use your graphing calculator to help you understand quadratics better. So let's see if you like it. The essential question for today is, how can my graphing calculator help me to understand more about quadratics? Here's the example. There's an apple, and I'm going to draw a perfect little heart-shaped apple. There it is. You drop that perfect little heart-shaped apple from the top of the 378-foot twin center. Did you know that the twin center is the tallest building in Morocco? So you're like, I'm gonna drop an apple from the tallest building I can in Morocco, and you drop it from the top of that twin center. We want to model this situation with the free fall equation. And the free fall equation, as long as you're working on Earth and in feet, it's gonna be this. With different gravities, like if I was on the moon or on Jupiter, this equation would change, because obviously if you have a bigger gravity pull, your apple is going to fall faster, or it's going to accelerate faster, I think would be the proper term for it. Anyway, let's think about what happens when you drop an apple. Let's just kind of visualize the situation. I'm standing on top of the building. Let's draw the building. Actually, let's draw the building over here on the graph. And you drop an apple, here you are, and this apple, it's gonna fall faster and faster and faster, right? Until it hits the ground, because it's accelerating the whole way down. It doesn't just fall at this nice leisurely pace, No, it's getting faster and faster and faster as it goes down. That's why it's dangerous to fall from greater heights, because you're getting faster as you go, which increases your force, blah, blah, blah. If you take physics, you can learn all about these things. Anyway, I want to know, using this equation, my first question is, when does the apple hit the ground? Now we're going to need to plug some things in. First of all, when t. Like, I'm solving for t in this equation. So when I rewrite my equation, t is the variable. H is going to be the variable that represents height. And it's going to be the height at different times t. So basically, after 1 second, how high is it? After 2 seconds, how high is it? After 3 seconds, how high is it? So h and t are changing depending on what time you're using. Obviously, if it's 300 seconds later, it's probably hit the ground. H sub 0, or H naught as we sometimes like to call it, is the initial height of the apple. So this is what we call a constant. I can plug this in right away. So let's think about some things that I know. What is my H? What is my T? What is my H naught? Well, I said that I'm going to be solving for T. So let's leave T in the equation. H sub 0 is the initial height, and since I'm standing on top of the twin center, instead of H sub 0, I'm going to write 378, because that's the height of the twin center. Now, what is H? Remember, H represents the height at different times t, and remember, I'm solving for the t of when it hits the ground. So when the apple hits the ground, what's the height? Isn't the height 0? Because if it's hit the ground, it no longer has a height. The height is 0. So this is the equation I'm going to solve. I picked 0 because h is the height that the apple's at, t is what I'm solving for, and 378 is my initial height. Okay, let's solve this. Since I only have t squared and not an additional t term in there, I can solve using square roots. So let's isolate the t squared. I'll subtract 378 from both sides, so that's going to be negative 378 equals negative 16t squared. Let's divide both sides by negative 16. So let me do that in my calculator real quick. I have 378 divided by 16. The negatives are going to cancel. That's 23.625. And to cancel the square root, I simply need, to cancel the square, I simply need to take the square root, right? So if I do the square root of the answer, that gives me 4.86, and that would be in feet. Oh, no, this is time. That's not in feet. This is in seconds. So t is 4.86 seconds. Remember that when we take the square root, I could also have a negative here. But does the negative make sense in this context? No, it doesn't. I'm not plugging in negative times. So the apple is going to hit the ground at positive 4.86 seconds. So that's all well and good, but I want to actually graph this function because remember, t could represent any time. Like maybe I want to know exactly how high the apple is 2 seconds after I've dropped it. It's falling somewhere, but how high is it? So I'm going to graph the function here, and the function I want to graph is h equals negative 16 t squared plus 378. 378 because that's my initial height, t because t is changing, right? I'm finding at different times, and h is also changing. The apple is at different heights depending on how long after it's been dropped. So in order to graph this equation, let's go ahead and put it into the calculator. So I'm going to go y equals, let's go negative 16, just use x, that'll be represented by t squared plus 378. Now, we have to be a little intelligent. If I just graph it right now, it's not really going to show up nicely, right? It just looks like two straight lines. Why is that? Well, that's because this is so high. I know that at time 0, what is my height going to be? In other words, right before I drop the apple at time 0, aren't I still at 378? And let's look at the table to see that. Look, when we look at the table, let me just table set, we'll start at 0. Okay, so when I look at my table, look, I'm up at 378 feet, and that should make a lot of sense because it's right before I've dropped the apple. So if I'm scaling my axis, let's scale by hundreds, 100, 200, 300, 400. At a time of 0, I'm up here at 378. At a time of 1, according to my table, I'm at 362. At a time of 2, I'm at this is not 362. This is 362. At a time of 2, I'm at 314. At a time of 3, I am at 234. And at a time of 4, I am at 122. So it's making this nice parabola until it hits, and we know that it hits at 4.86. So if I go over 4.86, that is when it hits the ground. Now, in order to show this on your calculator, the nice parabolic curve, I need to adjust my window. So if you click on window, that would, let's see, my x max is 0 because I'm not plugging in negative times. Let's make my x max 5 because I know that it hits the ground at 4.86, so I don't need to go past that time. The y minimum, well, I'm not going underground, I'm staying at ground level, so the y minimum is 0. And the y maximum I know is 378, so let's just put the window up to 400 so that I can see the top. And let's see what this graph looks like. Hey, there's that nice parabola, and notice it's, going down. It's clearly starting at 378 and ending when it hits the ground. Now, some things to notice here. In free fall motion, notice how the apple is falling sort of slow at first, and then it's falling faster and faster as it hits the ground. Again, that's because it's accelerating as it goes down. It's a physics issue. One last thing, well, two last things, and then we'll get on to the domain and the range. If I wanted to see where the apple is at different times, I simply go to those different times. So at 1 second, we said it was up at like 374, I think. At 2 seconds, it's up at 314. At 3 seconds, it's up at like 225. So I can see how high the apple is at different times using this equation. Pretty neat. Let's talk about what the domain is. Remember, the domain is all of the reasonable values I could input. In this case, I'm inputting different times. And so what values make sense for time? Well, I said I can't go lower than 0 because I'm not a time traveler. I'm not plugging in negative times. So 0 has to be less than or equal to t. Also, we said that it hits the ground at 4.86 seconds. it doesn't really make sense to go past 4.86 seconds, does it? Because I'm not going underground. The apple isn't like penetrating beneath the earth and going all the way to the core. So I'm gonna stop the time at 4.86. It doesn't make sense to go past that because that's the exact moment the apple hits the ground. Finally, what is the range? This is the output, remember? The output here is heights. I'm putting in a time, I'm getting out a height. The highest the height can actually be is at the top of the twin center, 378. The lowest the height can be is at 0 because it's hit the ground. So height needs to be between 0, the ground, and 378, the height of the building. One last thing I want to show you, sorry this video is getting a little long, but this is very helpful, so I hope you stuck with me. I could find this 4.86 using the calculator. This is the x-intercept, isn't it? In other words, it's the 0 because it is a height of 0. It is a y of 0. Your calculator will do that for you. If you go to second calc, it will calculate the 0 for you. In other words, it's calculating when the graph hits the x-axis. What you want to do is you want to give it a good first guess. So I can arrow over to the right here, and it's wanting a left bound. So I know that the 0 is past this point, so I'll hit enter. Now it wants a right bound. So I'm going to go past the x-intercept into where I can't see, into where it's negative, and press enter again. Last, it wants a guess, so you should put the cursor right on the 0 or close to it. So I don't know if you can see this, but that cursor is very close to the 0, and I'm going to hit enter. Notice the calculator says a y of 0 and an x of 4.86, and that's exactly what I found. So again, to use your calculator to find zeros, you can hit second calc, do the 0 function. You need to put in a left bound, so put your cursor to the left. Then a right bound, so move your cursor to the right. In this case, it's off the screen. Then give it a guess, so put your cursor directly on where you think it is, and it will tell you what the 0 is. Pretty useful. Guys, sorry for the length of that video. I kind of droned on and on and on, but hopefully I showed you some useful things both with your calculator and how to calculate some real-world problems. Thank you very much for watching.